The deep ocean, a realm of mystery and wonder. Despite harsh conditions, life thrives. Today, we embark on a journey into this hidden world. From sunlit waters to the deepest trenches, we'll investigate the significance in these vast depths. Get ready to be amazed by the beauty and complexity of the deep ocean. Our exploration begins at the surface, where sunlight dances on the waves. We'll descend through the water column, each layer revealing a new world. We will encounter strange creatures, learn about hydrothermal vents, and discover how scientists use cutting-edge technology to explore this environment. Let's start with the epipelagic zone. Extending from the surface down to 200 meters, this zone is the ocean's most productive layer. Here, photosynthesis fuels a vibrant ecosystem. Schools of fish, sea turtles, and dolphins thrive in this realm. Predators like sharks and dolphins maintain the balance of the ecosystem. The epipelagic zone is a kaleidoscope of life. Coral reefs burst with color and activity. Fish, sea anemones, and jellyfish create a vibrant underwater city. Whales and dolphins migrate through these waters. The epipelagic zone is a testament to life's adaptability. As we descend deeper, a new world of shadows and mystery awaits. Entering the mesopelagic zone, we find a realm of fading light. This twilight zone marks a dramatic shift from the world above. Creatures here have evolved remarkable adaptations to survive. Large, sensitive eyes capture the faintest flashes of bioluminescence, a mesmerizing ballet of light. This serves as a defense mechanism for many creatures. Many animals here have large mouths and expandable stomachs for infrequent meals. Daily vertical migrations highlight the interconnectedness of ocean layers. Plunging deeper, we enter the bathypelagic zone, a realm of perpetual darkness. This midnight zone is a world of extremes, yet life finds a way. The pressure is immense, and the water is near freezing. Bioluminescence provides the only light. Despite challenges, the bathypelagic zone teems with life. Here, life has evolved stunning adaptations. Soft, gelatinous bodies withstand crushing pressure, as well as unique sensory adaptations to help navigate and find food. In this zone, energy conservation is key. Slow metabolisms allow survival on infrequent meals. Slow reproductive rates ensure offspring survival. Vampire squid change buoyancy to float effortlessly. These adaptations showcase the delicate balance of energy in this extreme environment. Next, we enter the abyssopelagic zone, a deeper realm of perpetual night. A fine, silty rain of organic matter, known as marine snow, provides vital food for deep-sea creatures. Life here is small and scattered, adapted to survive on meager offerings, displaying life's tenacity. This goes to show that even in difficult conditions, life finds a way. Lastly, we reach the hadopelagic zone, a realm of unimaginable depths and extreme conditions. This zone, named after Hades, the Greek god of the underworld, encompasses the deepest trenches and canyons on Earth, plunging from 6,000 meters to the very bottom of the Mariana Trench, nearly 11,000 meters below the surface. The pressure is almost unfathomable, over 1,000 times greater than at sea level, enough to crush an armored tank. The water is near freezing, and the darkness is absolute. The creatures that inhabit this realm are often small and gelatinous. Many are blind, relying on other senses, like touch and smell, to navigate and find food. Food is scarce in this deep-sea desert, and many creatures are scavengers, feeding on the carcasses of dead animals that sink to the bottom, or the occasional bounty of marine snow that drifts down from the surface. But in this zone, it isn't too rare to run into creatures that seem to have sprung from science fiction, like the anglerfish, with its bioluminescent lure attracting prey, or the giant squid who roams these depths, its massive eyes scanning the darkness for prey. There is also the goblin shark, a living fossil whose length averages from 8 to 11 feet, though some have recorded being up to 20 feet. This shark features an elongated snout armed with sharp teeth. These waters are also home to the Dumbo octopus, with ear-like fins. Its graceful movements make it one of the most enchanting creatures in the deep. This diverse, unique ecosystem reminds us of the deep ocean's endless wonder and discovery that we are still working to explore and better understand. Bioluminescence is the ability of living organisms to produce and emit light through chemical reactions within their bodies. It's a phenomenon that's as beautiful as it is essential for survival in the depths, where sunlight dwindles to nothing more than a distant memory. In this world darkness, bioluminescence serves a multitude of purposes, from attracting mates and luring prey to deterring predators and even communicating with other creatures in the abyss. One of the most iconic examples of bioluminescence is the anglerfish, a master of deception that dangles a glowing lure in front of its toothy maw, enticing unsuspecting prey into its grasp. Other creatures, like the hatchetfish, use bioluminescence for counter-illumination, masking their silhouettes against the faint light filtering down from above, making them practically invisible to predators lurking below. But bioluminescence is not just about hunting or hiding. For many creatures, it's also a way to find a mate in the vast darkness of the deep. Some species of squid, for example, use flashing patterns of bioluminescence to attract potential partners. Their light displays as unique and intricate as any courtship ritual on land. Hydrothermal vents are fissures in the ocean floor where geothermally heated water spews forth, carrying dissolved minerals and chemicals from the Earth's interior. These ecosystems rely on chemosynthesis, where bacteria use chemical energy from the vents to produce food. This supports a diverse community of organisms, including giant tube worms, vent crabs, and fish. The extreme temperatures around the vents can reach up to 400 degrees Celsius, or 752 degrees Fahrenheit, yet remarkably, life flourishes here. The mineral-rich waters precipitate to form towering chimneys known as black smokers and white smokers, depending on the minerals present. These unique structures provide habitat for a variety of specialized organisms that are adapted to the high-pressure, low-light conditions, like vent mussels, vent shrimp, as well as vent snails. Hydrothermal vents also play a crucial role in regulating the chemistry of the ocean and contribute to the global cycling of elements such as sulfur and carbon. The deep ocean, with its various landscapes and vital role in regulating our planet's climate, reflects immense value. Yet this hidden world faces growing threats from human activities. Climate change is warming ocean waters, leading to ocean acidification and disrupting deep-sea ecosystems. Pollution from plastic waste, chemical runoff, and noise pollution is also taking a toll. Deep-sea mining poses a significant threat to these fragile ecosystems. Protecting the deep ocean is about safeguarding our planet's health. International cooperation and sustainable management are essential. In ancient times and continuing on for centuries, the deep ocean remained unknown, a realm hidden from human view by its vast depths and seemingly boundless stretches. But with the advent of new technologies, we are finally beginning to peel back the layers of darkness and explore these deep waters. One of the most important tools in our deep-sea exploration arsenal is the remotely operated vehicle, or ROV. These unmanned submersibles, tethered to a surface vessel by a cable, are equipped with high-definition cameras, powerful lights, and an array of sensors that allow them to collect data and samples from the deep. Advancements in marine biotechnology are changing how we find new medicines in our oceans. These vehicles are key technologies, allowing scientists to explore and collect samples that have led to the discovery of bioactive compounds from marine sponges and other organisms. Many of these compounds fall into categories such as antibiotics, antiviral drugs, and anti-cancer agents, offering new hope in the fight against resistant infections, cancer, and other diseases. Collecting these marine resources combines old and new methods. Initially, divers gathered samples from shallow waters, but now we use deep-sea trawling and ROVs with robotic arms for precise collection. Once collected, they are analyzed in laboratories using techniques like mass spectrometry, which measures the masses of molecules, and high-throughput screening, which rapidly tests thousands of samples for biological activity. These technologies help identify useful compounds quickly and ensure sustainable practices to protect marine ecosystems. ROVs like Jason and Hercules have revolutionized our understanding of the deep ocean, capturing stunning images and video footage of hydrothermal vents, shipwrecks, and bizarre deep-sea creatures never before seen by human eyes. For a more immersive experience, scientists can also venture into the depths aboard human-occupied vehicles, or HOVs. These submersibles, like Alvin and the Deep Sea Challenger, are capable of carrying scientists to depths of thousands of meters, allowing them to observe the deep-sea environment firsthand. The experience of descending into the abyss in an HOV is both exhilarating and humbling. These technological marvels, combined with the ingenuity and determination of scientists and engineers, are opening up the deep ocean to exploration like never before. Intrepid explorers have always pushed the boundaries of human knowledge. Pioneering expeditions have forever etched their discoveries in oceanography. The HMS Challenger expedition is considered the birth of modern oceanography. It collected unprecedented data, discovering over 4,700 new species. In 1960, Jacques Piccard and Don Walsh reached the Challenger Deep, the deepest point on Earth. In 2012, James Cameron captured stunning 3D footage of these waters. Ongoing missions by NOAA and OceanX continue to reveal the secrets of the deep sea. Sonar, short for sound navigation and ranging, is a technique that utilizes sound waves to detect, map, and identify underwater objects and features. In the harsh environment of the deep ocean, where visibility is zero and conditions are extreme, sonar is an indispensable tool for explorers. It emits vibrations and listens for the echoes from objects. This helps create detailed maps of the ocean floor. Sonar has revolutionized our understanding of the deep ocean. The ocean floor is a dynamic landscape of mountains, valleys, and volcanoes. Sonar locates hydrothermal vents, shipwrecks, and other features. It's also a tool for studying marine life. Scientists track fish, whales, and other marine animals. This helps manage fisheries and protect endangered species. The deep ocean is a world of interconnected ecosystems crucial for regulating our planet's climate. It's a source of food, medicine, and endless wonder. Our journey into the deep ocean may be ending, but the wonder and call to action remain. We've seen the beauty and fragility of this hidden realm, linked to our own world. It's a place of mystery, with countless undiscovered species. This realm inspires us, showing evolution's creativity and life's interconnectedness. We've gained a new perspective on our place in the grand scheme. Though the deep ocean is not immune to our influence, nature's power to create and destroy is evident. Our oceans inspire us, showing evolution's creativity and life's interconnectedness. We've gained a new perspective on our place in the grand scheme. Though the deep ocean is not immune to our influence, its glorifying power to create and destroy is evident. Thank you for joining us on this journey. May the wonders we've witnessed inspire us to further our knowledge of the world.